Welcome all. This is Dr.G.P.Halde ECE, Assistant Professor from the Department of Electronics and Communication, Priyadarshini College of Engineering Nagpur. Today I am going to discuss about the various basic operations performed on a signal. There are two types of signals, mainly the continuous time signals and the discrete time signals. Today I am going to discuss it about the continuous time signals operations. So there are basic three signal operations which can be performed on the continuous time signal. First is the scaling, the second is the shifting, and third is the inversion. The scaling can be further viewed as the amplitude scaling and the time scaling. The amplitude scaling signal is equals to y of t equals to a into x of t, where a is the scaling factor. So in amplitude scaling, the amplitude of the signal gets multiplied with the scaling factor. Whereas for time scaling, the output signal y of t is equals to x of a into t, or y of t is equals to x of t by a. That means the time parameter or time value of the signal is either get multiplied with the scaling factor or it gets divided by the scaling factor. The resultant from this signal is thus either appears to be a compressed signal or it appears to be an expanded signal. The second operation performed on any signal is the shifting operation. The shifting operation again can be viewed as amplitude shifting and time shifting. For amplitude shifting, the output signal y of t is described as x of t plus or minus a. That means the shifting constant is actually added to the existing signal values. That means the amplitude of the signal gets shifted by the shifting constant value. Whereas for time shifting, the output signal y of t is equal to x of t plus a, or it is y of t is equals to x of t minus a. That means the shifting operator or shifting constant gets added or subtracted from the time value of the signal. So the amplitude remains constant but time changes. The third operation is the inversion operation. It is again categorized as amplitude inversion and time inversion. Whenever it is an amplitude inversion, the resultant output signal is y of t is equals to minus x of t. That means the signal gets inverted along the x-axis. And in time inversion, the signal output signal is described as y of t is equals to x of minus t. That is, the signal here gets flipped around the y-axis. So we get, with the time inversion, we get the mirror image of the original signal. So these are the basic signal operations. Now to understand these signal operations more clearly, we can have one Scilab software on which we can plot these signals after performing these basic signal operations, so that it can be more clear to you the concepts of these basic signal operations. So here Scilab is a platform, open source platform. It is similar to the MATLAB, but MATLAB is a licensed software. So Scilab is the open source alternative for the MATLAB. All the operations performed in MATLAB can also be performed in the Scilab. Now here in the Scilab, I have written three codes, the one for the time scaling, or one for the scaling operation, the other for the shifting operation, and for the inversion operation. Now first I will run this code for the time scaling operation or the scaling operation. After this, running this program, it asks you for the scaling factor. So I will enter the scaling factor of 2 here. Now after the scaling factor is entered, here are the plots for our operation of scaling, for amplitude scaling and then for the time scaling. You can see on the left side window, this is the amplitude scaling operation, the original signal. You can observe that the x-axis is from 0 to 2 and y-axis is from minus 2 to 2. But for amplifier signal, the x-axis remains the same, that is from 0 to 2, but y-axis is further more than that. You can see the divisions, although the numbers are not displayed here. For that, we have to set the axis property of this plot. Then next is the attenuated signal. Whenever the signal amplitude is decreased by some factor, we call it as an attenuated signal. So here in this attenuated signal, the x-axis or time values are remaining same, that is from 0 to 2, but the amplitude is scaled down from -1 to 1. as compared to the original from -2 to 2. Now come to the time scaling operation. For the time scaling operation, the original signal is again from extending from 0 to 2 in time axis, whereas for y-axis or value axis it is from -2 to 2. The compressed signal, you can see the amplitude axis, that is y-axis, is same from -2 0 to 2, but the time axis has been gone to 4, and clearly it is visible that the signal appears to be compressed. Whatever appearing in the original signal at some later instant, in this that event is occurring or that value is taken earlier. The third one is an expanded signal. For the expanded signal, you can see that the time axis is from 0 to 1, so that the signal is expanded and it is clearly visible from this graph. However, the amplitude values from -2 to 2, it remains the same. So this is about the scaling operation on the time. Now we will see about the shifting operation of the signal. So for time shift, I'll run this code. Again here it will ask the shifting parameter or shifting constant. So I have entered that. After entering, these graphs are plotted. So you can see these graphs. On the left side, again it is the amplitude shifting operation. So again the original signal is from 0 to 2 on the time axis, whereas on value axis or y-axis it is from -2 to 2. Now the second one is a upshifted signal. That means the shift operator is added to the amplitude of the original signal. So you can see that the original signal was from -2, it was starting from -2, but now it has been shifted to 0 value. That means +2 is getting added. So it means that the signal was shifted upwards by a value of 2. Similarly, downshifted signal, you can see that the original signal was starting from -2, but since the signal is shifted downwards by 2 factor, therefore now this signal is starting from -4 and it is extending up to 0. So you can say that this is the downshifted signal. However, you can observe that the time axis values are same, that is from 0 to 2, 0 to 2 and 0 to 2 in all the 3 graphs. Now next, here on right hand side window, we will see the time shifting operation. Again the original signal is there and then it is a left shifted signal. Now since it is a time shifting operation, you can observe that the amplitude axis is same, that is from -2 to 2, but now the time has been shifted to -2. That means in original signal the signal was starting from 0 and it was expanding up to 2, but now in left shifted signal the signal is starting from -2 and it is expanded to up to 0. So it clearly indicates that the signal was shifted by an amount of 2 to the left side. Similarly, right shifted signal, the amplitude axis is same, but now the time value has been changed and now the signal is starting from 2 and it is extending up to 4 as compared to the original signal from 0 to 2. So here also it is clearly we can see that the signal which was earlier starting from 0, now it is starting from 2, so it has got shifted by an amount of 2 to the right side. So this is the shifting operation performed on the signal, and the last operation performed on the signal is the inversion operation. So again we will run this code for inversion operation. This is the output. The original signal is as it is. Now amplitude inverted signal, you can see that the amplitude inverted signal, in that the signal is clearly the mirror image, or it is inverted from that of the original signal. So whatever was the positive peak into the original signal, now that peak is a negative peak into amplitude inverted signal. Coming to the time inverted signal, you can see that the time axis for original signal was starting from 0 up to 2, but now for this time inverted signal, the signal time axis is started from -2 and the last point is 0. That means clear you can visualize this as around the y-axis the signal has got the mirrored, or it has got inverted along the y-axis. So this is the time inversion operation. So with this, I think you have got the idea or clarity about the operations, basic operations performed on signal. So be in touch with more such video. Thank you.